All right, class. In this video, we continue our discussion of section 6.2 in your note packet, integration by substitution. We're going to be picking it up at the bottom of page 79, and we are posed with the question, what happens if we want to use U substitution, but we don't have a perfect du? Well, the way it turns out is you can be off by a multiplicative constant in your calculation of du, and you can still use the U substitution method. So we'll illustrate that here with this example. We're going to find the antiderivative of x over x squared plus 1 with respect to x. Well, you'll notice in the denominator of this quotient, x squared plus 1, the derivative of x squared is 2x, the derivative of plus 1 is 0, and so the derivative of that denominator is 2x. We have the x, we don't have the 2. We're off by a multiplicative constant of 2, but we can still use the U substitution method. We set u equal to the denominator x squared plus 1, so the derivative of u with respect to x is equal to 2x. Now we multiply both sides by dx, and we get du is equal to 2x dx. And since we have the x dx, but not the 2, we divide both sides of this equation by 2, and you know multiplying or dividing by 2 is the same as multiplying by 1/2. And so on the left hand side we have 1/2 du, and on the right hand side the 2's cancel and we're left with x dx. So we're going to substitute 1/2 du for x dx. Now this quotient here can be broken up into a product of two quotients. I can write this as 1 over x squared plus 1 times x over 1, and x over 1 just simplifies to x. And now I do the substitutions. I replace x squared plus 1 here with u, so I have 1 over u, and I replace the x dx with 1/2 du. Now this 1/2 is a multiplicative constant, and you know from the basic rules of anti-differentiation it can be brought out in front of the integral sign. So I have 1/2 times the antiderivative of 1 over u with respect to u. Well, the antiderivative of 1 over u with respect to u, you know, is the natural log of the absolute value of u. And so that our antiderivative of 1 over u times 1/2 du with respect to u is equal to 1/2 times the natural log of the absolute value of u plus c. But we need our antiderivative in terms of the variable x. And so the last step is we replace u with what it's equal to, and u is equal to x squared plus 1, right? So we do the reverse substitution, put in x squared plus 1 in for u, and we have this is equal to 1/2 times the natural log of the absolute value of x squared plus 1 plus the arbitrary constant c. So this right here is the antiderivative of our original function with respect to x. At the top of the next page, top of page 80, we have an example 2, the antiderivative of e to the 6x over 1 minus e to the 6x with respect to x. Well, if you'll notice that the derivative of 1 minus e to the 6x in the denominator here, the derivative of 1 is 0. The derivative of e to the 6x is e to the 6x times 6 by the chain rule. Remember, when we differentiate e to the 6x, we got to use the chain rule. So the derivative of e to the 6x is e to the 6x, and then times the derivative of 6x, which is 6. So this derivative of 1 minus e to the 6x is just minus 6 times e to the 6x. Well, we have the e to the 6x. We don't have the minus 6, but we can still use the U substitution method. When I multiply both sides of this equation by dx, I get du is equal to minus 6 times e to the 6x dx. Right? I have the e to the 6x dx. I don't have the minus 6, so we divide both sides of this equation by minus 6. And remember, dividing by minus 6 is the same as multiplying by minus 1/6. So on the left-hand side, I have minus 1/6 du, and on the right-hand side, I have e to the 6x dx. Now, this quotient can be split up into the product of two quotients. I can write this one quotient as 1 over 1 minus e to the 6x times e to the 6x over 1, and e to the 6x over 1 just simplifies to e to the 6x. And now I do the substitution, right? I replace 1 minus e to the 6x with u, and I replace e to the 6x dx with minus 1/6 du. Now I put the minus 1/6 in parentheses so we don't confuse subtraction with multiplication. We're actually multiplying here. The minus 1/6 gets pulled out from the integral sign, and I'm left with the antiderivative of 1 over u with respect to u. With the antiderivative of 1 over u, we know is the natural log of the absolute value of u. And so now I replace u with what it's equal to. It's equal to 1 minus e to the 6x. And so I replace u with that. And then this is, in terms of x, this is the antiderivative of our original function. The antiderivative of this function with respect to x is equal to minus 1/6 times the natural log of the absolute value of 1 minus e to the 6x, and then we add the arbitrary constant c.